Okay, so I will share the screen with you. So in the last class, we started with the discussion on the transmission system, wherein we have seen the layout of two-wheel drive and the four-wheel drive. So that was the thing. Now, today we are going to discuss the transmission. We are going to discuss the transmission gearbox. What are the different types of the transmission gearbox, and what are the advantages, disadvantages of these things. Okay, so I will share the presentation. Now we have seen that a transmission system uses a clutch, gearbox, propeller shaft. This system we have seen the clutch, gearbox, propeller shaft and a differential gear to transmit power from engine to road wheels. The power may be transmitted to rear or front or all the four wheel depending upon the type of the drive used. The clutch gearbox, the clutch and gearbox varies the ratio of the torque output, torque output and to torque input. Now propeller shaft transmits final torque to the rear axle. This we have seen. The differential gear equally distributes the final torque between the road wheels. So this is the basic theory we have seen. Now here we are going to see in the next slide the function of transmission system. Actually disconnects engine from driving wheel when required. This is the function of the clutch. The engine is connected to driving wheels when required. Okay, again this is the function in clutch. Please understand that normally the clutch is engaged. Whenever you press the pedal, then and then only the clutch gets disengaged and you can able to shift the gear. So it changes ratio of torque output and torque input as desired. It turns the drive through right angle. Okay, so please understand that it turns the drive through right angle. So this is not exactly true, but this is the this is the function of the differential. This is perfectly correct. The function of differential is to turn the drive through the right angle. So he is describing the complete transmission system, right from the engine to the rear wheel. Now transmission system, it is used to transmit engine driving torque to the driving wheels to drive the vehicle on the road, driving wheels to drive the vehicle on the road. So this is the layout which we have seen. This is actually, it looks like this. This is the engine. This is the front end of the engine, and if you see this thing, this is what we have discussed. This is the belt system which is shown. This is the belt. Okay, so this is the belt system we have discussed in the previous classes. Now this is the engine. This is the clutch housing which I have drawn. Then transmission, then these are the universal joint, that is called as the U joint, and then it goes to differential, and we have seen that it can be distributed evenly to the two rear wheels. So this is the transmission system. Now vehicle gearbox. Out of this, we are going to focus our attention on the study of the vehicle gearbox. Usually you you see such kind of a lever in the driver compartment just besides the driver and co-driver seats. So gearbox varies the leverage, speed ratio and hence torque ratio between the engine and the drive wheels. It is located between the clutch and the propeller shaft. This we have seen. ये जो है ये यहाँ पे लोकेट किया रहता है. This is the gearbox. Okay. So it is located between clutch and the propeller shaft. It is provided with either 4-speed or 5-speed ratio or more depending on the design. Okay, usually now you can have the first, second, third and fourth gear which are there. So how do you can you tell me what is the location of the first, second and third you can say gear? Suppose let us say on the top of this lever the gear configuration is given. Okay, so if I draw like this, one moment. Let us say that this is the neutral line. So how the gears they are given here? So this is, say this is gear 1, this is gear 2, this is gear 3. Those who drive the car, they might be knowing that this is gear 4. Usually this is gear 5 and this is the reverse gear. This is the general configuration which is printed on the top portion of this gear level. I am saying that the general configuration, but recently I purchased the vehicle wherein the gear ratios are like this. So this is 1, 2, 3, 4, 5, 6. Yeah, this is 1, 2, 3, 4. Then this is 5. This is 6. And the reverse gear is given here. So this is, you can say, the reverse gear. Recently I purchased the vehicle wherein the configuration is like this. So sometimes it becomes very difficult for me to shift the gear. And the safety feature here in this gearbox is that they have given one notch here at the just below the reverse gear. That means the gear shift lever has got the notch over here. Unless you press that notch, the gear will not shift to reverse gear. That means whenever you wanted to take the reverse turn, then in that case you have to press this particular button. Then the rear camera gets on, and then then only you can take the reverse. So this is basically the safety feature. But this is also good that till now we are using this. This is recently added in some of the foreign vehicles. So that is what I wanted to tell you, what is the gear shift pattern. So all of you are aware on this, that the sometimes what is going to happen, this gearbox lever, it keeps on vibrating like this. So that is termed as the gear rattle. Most of the time you will see that such kind of gear rattle is there in old vehicles. Okay, so at the time please understand that the ball which is there inside for shifting of the gear is worn out. There is some play in that, and that is why such kind of thing happens. Okay, so we will see those things in detail. So right now this is the vehicle gearbox where you have got the gears which are mounted inside that. There is a gear train, and we are going to see that how the power is getting transmitted, exactly what happens when you shift to the first gear, second gear, third gear. All those configurations we have to draw. So now the next slide, it says that the types of gears which are used in the gearbox. So basic principle, the most basic type of gear is the spur gear. I hope you have studied the spur gear in your theory of machines class. Am I correct? Sir, आपने पढ़ा है क्या? Yes. So how do you define the pinion and gear in this? Let us say that in this particular picture, gear 1 and gear 2. So which is pinion and which is gear? सर इसमें पिनियन कौन सा है, गियर कौन सा है? Pinion with smaller diameter. Very good. So pinion with the smaller diameter. And usually in the gear 10, the smallest gear is termed as the pinion. The other ones of gear. And now suppose this is rotating in this direction. So where this gear will rotate? Suppose this is rotating clockwise. So this gear will rotate anti-clockwise. Is that okay? Yeah, opposite. Now Saurabh, just tell me, let us say that this gear is having 20 teeth and this gear is having 10 teeth. So what is the gear ratio? What is the formula for calculating the gear ratio? Okay. Any other answer? What is the formula, Saurabh? How do you get that 20? Sorry, 2. TG by TP. Suppose if both the gears they have the same teeth, like what here they have the same teeth. Let us say this is 20 and this is let us say 20. Now if I make this as driving gear and this as driven gear, what is the gear ratio then? Is it some relationship between the driving and driven gear, or it will be still 2? Sir, please let me know what is the formula. Follower by input means what, sir? Follower, where is the follower? Which one is follower? So by that it will come 2 if you, so gear is follower. So you are talking about the first case or second case? Let us say I make 20 as the driving gear and 10 as the driven gear. So what is the gear ratio? You have said 2. Now if I make it the driving gear teeth divided by driven gear teeth. Okay, okay, okay. चलो ठीक है, तो ये सर अपन आगे देखेंगे कि क्या है गियर रेशियो. Okay. Now the most basic type of gear is a spur gear and it has a straight cut teeth. Okay, so these are the straight cut teeth where the teeth are cut parallel to the axis of the gear. So if you say that this is the axis of the gear, then in that case the teeth they are cut parallel to the axis of the gear. Okay, and now this is one configuration. The other one is wider gears and those that are cut for smoother meshing are cut with the teeth at an angle. These are called as helical gear. So which one is good, sir? Helical gear is good or the spur gear is good? Helical, sir. Why it should be good? Helical gear. Can you tell any of the drawback of this spur gear? Helical is noiseless and smoother. Okay. What about the spur gears? Gradual engagement is possible in case of which gears? Helical. Okay. Sir, tell me any of the drawback of this spur gear. Vibration, sir. Why it will vibrate? Backlash. What do you mean by backlash in the gear? Due to sudden engagement. Okay. Sir, please understand that there will be no axial force component as far as these spur gears are concerned. Okay. Because there is no angle given to the profile of the gear teeth. Whereas if you consider that there is an angle which is given here, so you may get the axial load here. That means the total force component for the power transmission, let us say if it is there, then there will be one component which is axial and one component which is tangential. So tangential component is responsible for the power transmission, whereas the axial component of the force is, if you draw the force diagram for this, the axial component of the force will give some problem as far as the fitment of the gear is concerned. So axial component is present here, whereas the axial component is absent here. This is very easy to manufacture spur gear compared to helical gear. Okay, so there are advantages of the helical gear. I'm not saying that, but the major problem with the helical gear, that means the moment you give the angle to the teeth, then there is a problem of the axial thrust, which will be more in this helical gear compared to your spur gear. Okay, so please keep these things in mind. Depending upon the arrangement, you have to select the gear. So you people are more intelligent than me because you have recently completed theory of machines, so you know better than me. Now, gears used in vehicle gearbox. Because of the angle cut, helical gear teeth have a much more gradual engagement with each other, and they operate more smoothly and quietly than the spur gears. Helical gears can transmit more torque because at any time more number of teeth are in mesh. So this is the advantage of the helical gear. So more number of, you can say, gear teeth, they are in mesh. Gearboxes for cars and motorbike almost always use helical gears. However, helical gears also exert undesirable axial thrust. This is what I have recently told you, that they exert undesirable axial thrust. Now, to prevent axial thrust, double helical gears are used which cancel out the thrust. Double helical gears are called herringbone gears. Okay, so this you are aware of. That means you have to have the double angle cut on the gear, so that is how you can avoid that axial thrust. But please understand that this axial thrust is the major issue as far as the these gearbox, the helical gears are concerned. Okay, and spur gears, they are easy to manufacture compared to helical gear. So is there any doubt on this particular slide? Shall we go ahead? सर आगे बढ़े? ओके, चलो तो अभी नेक्स्ट क्या बात करते हैं? दिस the gearbox speed variation. This is the typical speed variation for these five speed manual gearbox. So it says that first gear, usually the gear ratio is 3.166, second gear is 1.882, third is 1.296, fourth is given as this has to be point. There has to be some point over here, 0.97. So please correct it. 0.972 and fifth is 0.738. Usually the gearbox output shaft RPM, when the engine shaft RPM is 3000. So if you have, you just have to divide this particular thing by to the 3000 and you will get this particular number. So please here you understand that for gear 4 and gear 5, the output shaft rotate at more speed compared to what you see in the gear first gear, second gear and third gear. So usually such kind of thing is termed as the overdrive. That means the gearbox output shaft, the engine shaft rotates at the lower speed than the gearbox output shaft. Here, if you see that the problem with these kinds of things is the torque is very low in this case. That means if you want to overtake the other vehicle which is running on the highway, then in that case this will be not helpful. Please, so do not overtake the vehicle when you are in higher gear, that is fourth or fifth gear, or even for that matter third gear. Sometimes it is, nowadays it is okay with the engine speed varying to the 6500 for petrol engine, but that was not recommended previously for diesel. So usually when you have to overtake the vehicle, you need to get the acceleration performance more. So if you are in fourth and fifth gear, this is basically the fourth and fifth gear combination is used where you don't want to, you can say, overtake any of the vehicle, or there is no need of the power, so you just have to cruise the vehicle. So there you can use this fourth and fifth gear. So this is the typical value. Please understand that this is the typical example of gear ratio. I am saying typical, it is not hard and fast that these have to be followed. One more thing, these gear ratios of first gear and second gear, usually the second gear ratio is the geometric mean of the first and third gear. Here the one gear is missing. Can you tell which gear is missing? Just by looking at this chart, can you guess any gear which is missing from this particular list? Yeah, reverse is missing. So please understand that the reverse gear ratio is almost the same as the first gear ratio. So this is almost the same as the first gear ratio in most of the vehicle, because in first gear the torque is maximum. Please understand that we have got the formula that the power P is equals to 2 pi mt. Power P is equals to 2 pi, leave it. It is proportional to N and T. Okay, so this you can convert it. Now when if you require more speed, then torque has to get adjusted. If you require more torque, then speed has to get adjusted. So because this product will remain same, because for engine the power output is going to remain same, hardly it matters. Have you studied the engine characteristics? Sir, please let me know, have you studied the engine characteristics by any chance? Okay, so can you tell me what is the shape of the graph of the engine power? सर आप बता सकते हो क्या इंजन पावर? आपने एक जनरल स्टडी किया है? हैव यू स्टडीड द इंजन? आई एम जस्ट आस्किंग बिकॉज if you have not studied, I will tell you. Then and then only you will be in a better condition to appreciate this. So I will draw here the increase to peak and then fall. Very good. Good. So Pradyuman, you are correct. I will just draw for your information. So engine ये है आरपीएम, ये है पावर. तो सर ये जो है, ये आप यहाँ usually it is 800. If I am drawing it for the diesel and it is 4500. So somewhere the graph goes like this and comes here. Okay, this is more flatter. So this is the variation. So increase to peak and then falls. Any reason why it falls at the at higher RPM? So this is called as the rated RPM. Most of the time this gap, the peak and this is not too much. This is the rated. And if you ask me the torque, so torque is something like this. This is basically the flatter somewhere here, and slightly, if this is the middle, slightly in forward direction. This is basically the torque curve. Slightly ahead of mid RPM, torque curve gets its peak value, which we term as the max torque point. Okay, sir, my question is, why after this the engine power falls? Okay, why it goes down? As you have rightly pointed out, Pradyumna, frictional power increases. Okay, any other thing? Why frictional power should increase, sir? Correct, that is one aspect, that is correct, but why frictional power will increase? सर फ्रिक्शनल पावर क्यों बढ़ेगा? Power due to friction is proportional to square of the RPM. Okay, due to slippage and sliding. No sir, this is the formula. The frictional power is directly proportional to RPM, and as you have rightly said that after this your RPM is going to be more, so square of that RPM is one more. So this is the one reason. The other reason is less time to burn the fuel. Less time to burn the fuel. So as a result, you are able to burn very small amount of fuel, very less amount of fuel. So if you are not able to burn more amount of the fuel, how you are going to get the power? So that is why what you have to do, you have to turbocharge it, and then you can increase the power and RPM slightly. Okay, but not beyond this. Now please note that this is your rated RPM. Now when you multiply there is another term which is called as fly up RPM in engine characteristics. Fly up RPM. Fly up RPM is usually the rated RPM multiplied by some factor, let us say 20% factor, or you can say in some cases it is 25% factor. So this is whatever RPM you are getting, that will be more than this your rated RPM. So all your engine components, they are designed for this fly up RPM. Okay, so please understand that this fly up RPM is important as far as designing of the component is concerned, so that it can bear, it will not fail if at all the engine speed exceeds, or if something happens, or some unexpected you can say load is given to engine. So please keep this thing in mind. One last question in this discussion is whether for urban driving you will prefer the city driving, you will prefer the diesel engine, or vehicle fitted with diesel engine, or vehicle fitted with the petrol engine. What do you prefer, sir? Please tell me. Which engine will you prefer? Whether engine fitted with the gasoline engine, or vehicle fitted with the diesel engine? Please let me know. What is your opinion? Petrol for intercity. Saurabh, okay. What about others? They feel? बाकी लोगों का क्या कहना है? पेट्रोल इंजन फॉर सिटी. ओके, दोनों सौरभ बोलते हैं पेट्रोल, सब लोग पेट्रोल बोल रहे हैं. क्या बात है, पेट्रोल के फेवर में बहुत लोग हैं. प्रज्वल ने पेट्रोल बोला, सौरभ ने पेट्रोल बोला. ये प्रणय चापेकर आ रहा जा रहा, क्या है प्रणय, कोई कनेक्टिविटी का इश्यू है क्या? Diesel for more power, Devansh Singh Negi. Okay, so why you require more power in the city? आपको अगर सिटी में ड्राइव करना है, so why you require more power? Because you are not going to drive the vehicle at the speed of let us say more than 60. That 60 is itself is a very high speed if you are driving in a city. Devansh, sir, please note that. In which engine you have got the control over the injection of the fuel? Do you have any control as far as the petrol engine is concerned? The quantity of the fuel to be injected for burning in the combustion chamber? Or other way around, I will ask the part load performance of which engine is better, whether it is diesel or whether it is petrol? Part load performance of which engine is better, whether it is petrol or whether it is diesel? Sir, have you studied engine? So sir, छोटी छोटी चीजें हैं sir. Try to understand the basic logic. See, in diesel engine, you have got the control over injection of the fuel into the combustion chamber. So part load performance of the engine is diesel engine is better compared to petrol engine, because in petrol engine you don't have any control over the quantity of the fuel. You have to just mix the fuel with the air and put it into the combustion chamber. So therefore, if you are driving in a city, you are not driving your vehicle for full load. Okay, you are always driving the vehicle with the part load. So diesel vehicle will give you better efficiency at the part load compared to the petrol engine. But we have in our mind that the diesel engines, they are to be used for the for highway driving, and the petrol has to be used for the city driving. It is basically the petrol engine is light, that is one thing, in weight. So that is one thing, and it is not noisy compared to the diesel engine. So that is why we prefer to have the comfortable drive. That is why we go for the petrol. But nowadays, with the technology, the diesel engines are so smooth that you can drive the diesel vehicle on the road. And you might have seen that a lot of vehicles, they are fitted with diesel engine. They are used on the in the city driving mode. Okay, so keep this thing in mind. So these are the general questions which have to be which you should know if from the point of view of your interview or the campus placement. So sir, थोड़ा सा अभी ये ध्यान रखिए. The maintenance is another factor, sir. Heavy engine blocks for diesel engine. Nowadays, there is no problem as far as the maintenance of the diesel engine is concerned. So it is the traditional thinking that the diesel engines, they have more maintenance, but that is not the fact. Okay. Previously, it used to be, but nowadays it is not the issue at all. Okay, with the electronics system are in place, you don't have to go for the diesel engine. Let me tell you, for that matter, about 2 lakhs kilometer, you don't have to touch to any of the component of the engine. Just you change the oil and run the engine, because the engines, they are being tested. The durability of the engine is tested almost for 10,000 working hours. So there is absolutely no issue as far as the diesel engines are concerned. The blocks and everything, they are very good. So there is not going to be much issue as far as the maintenance is concerned. So that was the wrong, that was in the olden days, but that's not true nowadays. Okay. So now coming to the gearbox, we have got the two types of gearboxes. The one is the manual transmission, that is sliding mesh gearbox. The other one is constant mesh gearbox, and the third one is the synchro mesh gearbox. So in this particular series, you will find that these two gearboxes, the last two gearboxes, ये जो दो gearboxes है, constant mesh gearbox and synchro mesh gearbox, they are almost same with slight variation. They are almost the same. Whereas this is the sliding mesh gearbox. This was in use. Now people don't use that. People use the constant mesh gearbox. And then we will have a small discussion on the automatic transmission, because this is very complicated aspect, and the continuously variable transmission. So this is how we are going to deal with the transmission gearbox system. So first of all, we will see the sliding mesh gearbox. Then we will have to solve some problems based on the sliding mesh gearbox and the constant mesh gearbox. So first, let us try to understand what is the sliding mesh gearbox. This is the layout of the sliding mesh gearbox. Please understand that you have to draw this layout in paper actually. Okay. So in sliding mesh gearbox, you have got the clutch shaft. Clutch shaft is basically the engine output shaft which is connected to clutch input, and clutch output shaft is connected here. So this is the clutch output shaft. The power comes from here. There is one gear which is in the constant mesh with the this particular gear which is fitted on the input shaft. So this is the constant mesh gear. That means it will come, the power will come from the clutch shaft to this another shaft which is called as the lay shaft or counter shaft. This is basically a dummy shaft, okay, on which the gears are mounted. Okay, now this is the output shaft. So this will rotate. Now we have to transmit the power from this lay shaft to the output shaft, and this is the gearbox output shaft. So this is how what we need to understand. So कैसे होगा सर कि ये स्लाइडिंग मेश गियर बॉक्सेस में यहां से आपको पावर आएगा. देयर विल बी पावर विच इज गिवन टू दिस इनपुट. Then on this particular input shaft, there is the clutch gear which is mounted. This is called as a clutch gear, but this is the part of the gearbox. Now this gear is in constant mesh with the gear on the lay shaft. Okay. And now we have to transmit the power. Right now this is in neutral condition. That means whatever RPM is coming in, the only lay shaft is getting rotated and it is not getting transmitted to your output shaft. So this is the gearbox is in neutral condition. Exactly what is going to happen that we are going to see. Please understand that this is the conceptual stage of how the sliding mesh gearbox is. So this is input, power in, then it will come here. Then now it will come to your lay shaft. Now we will see that in different gears what happens. Okay. Now this is showing the actual layout of the sliding mesh gearbox. The part 1 is the main drive gear. एक कहाँ बताया, चलो ठीक है, मेन ड्राइव शाफ्ट चाहिए, ये गियर गलत है. Part 2 is the counter shaft. Part 3 is the main shaft. So this is the main shaft, this is the counter shaft, and this is the main drive shaft. It has to be main drive shaft. सर ये थोड़ी सी इसमें गलतियां है प्रेजेंटेशन में, तो इसलिए सर मैं थोड़ा सा समय ले रहा हूं आपको ये प्रेजेंटेशन भेजने के लिए. बट डेफिनेटली आई विल सेंड यू, डोंट वरी अबाउट दैट. बट टिल दैट टाइम everything is given in the book, so please purchase the book and read that. Let me tell you that even if you purchase the book, your money is not going to go waste. It is going to give you some additional knowledge as far as the automobile is concerned. And please note that the automobiles, they are going to stay with us forever. So please don't think that whatever you are learning is only from the point of view of the examination and other thing. That is not the thing. But the knowledge of the automobile as a mechanical engineer, one should have that, because it's a beautiful, you can say, combination of all the subjects which we learn in mechanical engineering, and day by day the sophistications are going to get into it. And now the advancement in the technology is too much, but basic has not changed too much, let me tell you. Okay, so don't say that it is not, whatever we are saying is not relevant. No, it is going to be 100% relevant. Believe me that if you go with this particular course done here in the institute, and if you go to the industry, definitely I guarantee you that you will be much ahead of the people who are from other colleges. Okay, why I am saying so with this particular confidence? Because I have actually worked in the industry, and I know that what is the problems with the students who join the industry. They do not know much about the vehicle systems, how they work, what is the way to look at the vehicle from technical point of view. And from my experience, whatever difficulties I have faced during my company tenure, I am trying to save you. I am trying to give the information, the first-hand information, which is not available in the book. Okay, so that is how I have full confidence that if you do this course and if you listen to what I am trying to tell you, what I am trying to convey you, you will be definitely ahead of the people who will be joining the automotive industry. This is a challenge from my side, and I challenge you that when you join the industry, please do share the feedback, whatever I have taught, whether it is not there in the company. Okay, so now in sliding mesh gearbox, normally 3 forward and 1 reverse gear ratios are present. It is saying normally, but that is not the hard and fast rule. So 3 forward and 1 reverse. Basically, this engagement is there. Now we have these gears, they are fixed. Only the gears on the main shaft they can slide. And this is the component which you are going to see. These are called as the dog clutch. Okay, this is again, if you see 7, this is the top gear engagement dog. This is called as the dog clutch. Okay, I'll show you in the next slide, don't worry. So spur gears are used in the sliding mesh gearbox. Gear wheels on the main shaft engage with the gear wheels on the lay shaft, counter shaft, by sliding themselves. Please understand that these gears, they are fixed. These gears, they are fixed. Whereas these gears you can slide forward and reverse. How? That we are going to see the engagement. Okay, not used in automobiles now because these suffers from certain drawback that during the engagement there is a problem of the gear chatter and other things. The engagement is not smooth, so nowadays it is not used, but previously it used to be there in the vehicle. So we are saying all there right from the beginning to the today's transmission system. Okay, so is this clear? All the parts are clear. Please understand that the main shaft is this splined one. These are the splines which are present on the main shaft. Okay. तो सर कोई इसमें डिफिकल्टी है सर? आगे बढ़े? Yeah. Now coming to the next thing, the first gear engagement. Now see the carefully. The first gear engagement. What it is saying, gear 1. So power will come from here. It will be getting transmitted to here from the main shaft gear to the lay shaft gear. Now this lay shaft will rotate. You slide this particular wheel, okay, and engage with the pinion on the lay shaft, and that is how. And this gear is fixed with the main shaft gear. Please try to understand. It can slide as well as it is fixed with the main shaft in this spline. So now the main shaft will start rotating with this, and you get the power at the output. Okay, this is as simple as that. If you want to see the exact configuration here, this is the line sketch which we require to draw actually when we are discussing the transmission, you can say gearbox. Okay, so gear 1, 2, 5 and 6, this is 1, the power is coming from here, goes to here, from here it will go here, and then from here it will go to the output. That means this end of the gearbox is connected to the propeller shaft. So this is going to be the propeller shaft, and this is coming from the engine clutch. Okay. So this is basically the path for the power transmission in the first gear. So likewise, please note that here this gear can slide. This gear can slide. Whenever we see that we have to shift the gear for the reverse, then this gear has to be slided. This is basically the pinion which is adjusted, which has to be adjusted. Okay, so this is the first gear power transmission. Is this clear? Anybody is having any doubt in the first gear power transmission diagram? Sir, please say yes, no. Then and then only we'll go to second. Okay. Chalo, no doubt. Now the second one is basically this is the second gear transmission. Now you see that this is the power which is coming in. This is in constant mesh, power going here. It is power going here. Please see that this is the shifting mechanism. The complete thing is the shifting mechanism. So this gear can slide on the main shaft. So this is the second gear, how the power is getting transmitted 1 to 2, 2 to 3, 3 to 4. So 1, 2, 3, 4, this is shown here. This is the power transmission shaft and you get the power output from. So this is easy. Once you understand the first gear, the second gear configuration is easy. Now which gear would be engaging in the third gear? See this pair will be first gear. This is second gear. And what about third gear? There is no gear which is available on the main shaft. Do you notice this? So what may be the mechanism of transmission in the third gear? Because it is saying that the three forward and one reverse. So it is a 4-speed gearbox with 3 forward and 1 reverse gear. So what may be the case for the transmission of the power in the third gear? सर प्लीज लेट मी नो क्या हो सकता है सर पावर ट्रांसमिशन का थर्ड गियर में कैसे काम करेगा ये गियर बॉक्स क्लच शाफ्ट कनेक्टेड टू मेन शाफ्ट वेरी गुड which is the clutch shaft and main shaft will be connected but by this particular dog clutch. Okay, so you have to use this I will be showing in the next slide. So this is the power transmission. The power will come here and will straightway go to here, but still it will go here and will rotate this particular shaft. So this is the third gear position. So third gear means engagement. Here you see that the dog clutch, it has got completely engaged. So whatever power is coming in will be going straightway out. So what is going to be the gear ratio in the third gear for this? Yeah. So third gear ratio has to be 1, and now the last one, that is the reverse gear. This is the reverse gear which I was telling you that this is the engagement of the reverse gear. This is the same gear which was there in the first one, only because of the idler the direction will get reversed. Okay, so this is the this was the same gear which was engaging in the first. Let me show you the first slide. ये जो है सर ये फर्स्ट गियर में ये सेम गियर था सर, अभी ये गियर इसके साथ एंगेज हुआ है. Okay, so this gear has engaged with this, and that is the case which is shown in the reverse gear engagement. Only you put the idler here and the direction of the rotation will become reverse, and that is how you can achieve the reverse of reverse gear configuration. Okay, so this is how the gearboxes, the sliding gearbox, it works. Now we will discuss the constant mesh gearbox in the next class, but we are going to see that what are the problems with the sliding mesh gearbox, why we want it to shift to the constant mesh gearbox in the next class, and what is the configuration of the constant mesh gearbox. Okay, so with this we'll stop here. If you have any kind of difficulty, please do ask. I will try to answer your difficulties in the best possible way. Yes sir, any doubt, any difficulty? Whatever we discussed today. So if you do not have any difficulty, then you may leave the meeting. Over from my side.